Today at Nick's Garage, Nick is getting scientific. First, he'll use careful measurements and calculations to prove that some auto companies were telling us lies back in the day. And then, we'll be jumping into the 21st century with a demonstration of the power of laser beams.
Hi, I'm Nick and welcome to my shop. Yeah, today I'm going to do some educational stuff. More like a professor. You know, I've been working with a lot of 440s in my life. And you know, I've been reading books on them, high performance, 440, 6-barrel, 6-packs. And Chrysler always kept saying in all the shop manuals, Motor Trend, Chilton, shop manuals from Chrysler, that they were rated 10.5 compression ratio. Well, right here, I've got a 1970 Roadrunner V-Code 446 barrel. And of course, if I look at my shop manual, it says 10.5 compression ratio. But I've always told many of my viewers and my clients that they're not really 10.5. It's below that. Here, let me just show you also how to calculate it, and then also to tell you that it's not correct what Chrysler used to say, 10.5. What I've got here is an original 440 that came out of this V-Code 446 barrel Roadrunner, and it's all original. It's got the original piston, it's got a standard bore, it's never been decked, the heads were never shaved, and this is a perfect example for me to show you guys. So what I've got here set up is a dial indicator on a bridge. As you guys can see, this deck was never cut or milled, so this is a factory deck. It's a factory block, and it's a standard bore 4.320. Factory, never milled, all original. And of course, there's the stoppings from Chrysler. 440, F stands for 1970, 440 cubic inch HP, high performance. Now all the blocks are all the same. It's the internals that change. They put 6-pack rods, maybe a higher deck piston, a different cam, and so forth. So, matter of fact, I believe somebody changed the rings only in this engine at one time, only the rings, because the camshaft on our true 446 back should be 3 bolts. But somebody changed the cam at one time in this engine. But my point is the compression. Nothing's been changed or tampered with on this block for this reason. So this is why I'm taking this as an example. Let me get my breaker bar. Okay, now you can see my dial indicator is set at 0. So now what we're gonna do, see it's set at 0. Now we're gonna bring it here. We gotta bring the piston up to the maximum top dead center. So when it changes direction, is you know when it's at the highest point. So it's going to be right about there. Okay, so we're at the highest point. Let me put my breaker bar down. So as you guys can see with the naked eye, that piston is not level with the deck. It's below the deck. So now for this reason, we are going to lose compression. Cylinder pressure, compression ratio will be a lower number. Here we go. We dial indicator at 0. Now we bring it to the center of the piston. Look at the difference. There you go. We got about 55 thou below the deck. From 0, 50, and 5, 55 thou below the deck. Now, that's the one calculation we got. Like we said, we got a factory block here, never been touched, all original. So, now let's go to the engine room and take a look at the cylinder head and what head gasket Chrysler used. Let's go. You know, I have taken apart many 440s in my lifetime, and I've worked with 906 cylinder head. The 906 casting is the original head for 440 Magnum and also 440 6-pack or 6-barrel, which is right here, upside down, 906. This is the original casting to the cylinder head. This is the chamber. So what we have to do now, we have to measure the volume of the cc's in the chamber. Usually, factory cylinder heads that are not milled are 87, 88 cc. So let's check it to make sure. Now for this chamber, it's such an odd shape and form. We have to measure how many cc's. In this way, we measured with liquid. Now we put our valves in place, spark plug in place, and then we get our graduated cylinder filled with liquid, which is 50% water, 50% alcohol. So we set it at 0, if you can take a good look, you guys, this measures from 0 to 250 cc's. Now, factory chamber on a 440 should be 87 to 88 cc's. So let's see if we get there. So this is how I do it. I take some milling lube. This is like it's a semi-lube, but we're using it as a sealer. Like so. That's got a slight angle because we want the bubble to travel the air. Should I say like you see right now when I start to fill it. There we go. So now we take our graduated cylinder. And here we go. Let's see what cc's we're gonna get. Here we go, we start filling it up. And you want to make sure you got no air pockets there. There we go. There we go. So let's put this back on the stand. And it should be reading 87, 88 cc's. A factory non-milled cylinder head. So here we go. 75, 80, 85. Here we go. We got 88 cc's. Maybe 88 and a half, or a little more like 88. Okay, so now we have the volume of the chamber, 88 cc. Then, what gasket did they use for the cylinder head? Here it is. We have a cylinder head gasket from Chrysler. This is the part number used on 330-440s. It's a 20 thou shim, okay? It's a 20 thou shim gasket. And the bore here is 4 inches, 0.410 in diameter. So now, let's go on the computer, use my compression ratio calculator, and let's put all the numbers in and see what we get. Don't forget, factory said it did 10.5. This is the way I work with things. First of all, we go in inches, not metric. This one is made by csgnetwork.com. I've used this very often. I've used other compression calculators and they're all practically the same thing. So let's get started. So we're gonna work with inches. Now they ask you cylinder bore size. We did look at it. It's a 4.320 standard bore. There we go, 4.320 bore. Then, enter piston stroke. Our piston stroke is 3.750 on a 440. 750, 3.750, there we go. Next, we need to know the head gasket bore diameter. I said earlier, 4.410. 4.410. Next, the thickness of the gasket compressed, 20 thou. So there we go. We're going to put 20 thou there. Next, they're asking the cc in the chamber, the volume of the combustion chamber. We made a calculation of 88 cc. So then we enter 88 cc's. And then we go to type of piston. Some pistons have a dome, some pistons have a dish, some pistons have notches or valve release. This one is perfectly flat, so we put a 0, like so. Now, magic number is telling us enter piston deck clearance, negative if above. So we're not going to put a negative, we're just going to add the number that we have is a 0.055 thou below the deck. So it's 0.055, so 55 thou below the deck. Then we go over here and click on calculate compression ratio, and let's see what we get. There you guys go, 9.48. It's almost 9.5. And I've said that for many, many years. There's our number right here, right there, 9.48. If you go take a look at all that, I'm sure I did all my numbers correctly. No notches, no dish, no dome, it's a 0. And of course, 55 thou under the deck. And there we got it, 9.48. That is a true number you guys have been working with. And a lot of engines I build here, I zero deck them. I put maybe a 39 gasket, I shave the heads. I do most of my engines at 10.2 compression ratio with the cast iron heads, 10.1, 10.2. And of course, with the Petro Canada 94, you should have no issues. And there you have it, you guys, the true facts of a true compression ratio of 440. I've also shown you guys how to calculate compression ratio. And this goes for any engine you guys are working on. I wonder why Chrysler said it was 10.5. I don't know what kind of calculators you used back then. From today's technology, from what I know, I'm getting like a 9.48, 9.5 on this particular engine. Yes, so the other 440s are higher pistons, lower pistons, but in many cases, this is what I find. And you guys, I don't know why Chrysler said 10.5. This particular engine, stated 1970, V-Code 440 or Magnum 4-barrel high performance, should be 10.5 as stated in the Chrysler shop manual. But we got a 948 and those are real numbers. And you know, I like to do a little science once in a while with you viewers. Thanks for watching us here on Nick's Garage.
Don't go away just yet. Nick has some more automotive applied science coming your way. Check it out.
Well, you know, I'm old school. You know, when I've been working with cylinder heads, blocks, oil pans, timing chain covers, or water pumps, I used to work with the old days, dipping the parts in hot acid or sandblasting or tumblers. But today we got a new technology. I got Simon and Mike here from Evotech Innovations that are something new, something I've never seen. And it's something that doesn't make any dust, no liquids required, no scraping, scrubbing, breaking knuckles and everything, sandpaper or whatever you got to do to make something clean. So I brought in a cylinder head that's badly rusted. And they told me, Nick, we're gonna laser, what do you call that, Mike?
The laser cleaning.
Laser cleaning. So this is what they're gonna show me. So this is something new technology.
Yeah.
So I gotta see this.
Yeah.
I don't know how you guys are gonna do it. This is really, really rusted.
Good speed,
It's pitted.
to work on it.
Very badly pitted.
Yeah.
So you guys
Very
can,
nice to work it.
so you guys can make this look good.
Yeah.
I gotta see this.
Yeah.
So how did you guys come up with this invention?
Well, Michael and I, we worked for a couple of years together on different projects, and then we've seen this like new technology, and then we tried to perfection it a little bit. So, well, after a couple of years of work, now we come with this laser, these two laser machines. We're still progressing with our engineer to get like always better machine, but we have good final product here, and then you're gonna see how it goes.
You know, I just want to say they've come here in the past with a little machine, and they did some work. You know, it looked pretty good because it was something simple. But now they brought in the big Top Gun for something that's really rusted, pitted badly on this cylinder head that I want to use. So Simon and Mike,
Machine.
sorry?
The heavy duty machine.
Heavy duty machine, Top Gun I call it, okay. So I just want to see what you guys can do with this because I plan to use these cylinder heads. So they're very rare, I want to get them clean. But you know, there's no more acid dipping in Quebec. In some provinces, some states, maybe it's illegal. So laser cleaning, there's no chemicals or pollution or anything wasted on the floor into the sewer. So this might be the next thing on the industry.
The next technology in the industry for cleaning. Yeah.
So you have this technology, and I really want to see it. I got to see this, guy. So give us a little demonstration.
Let's go. Okay, let's go.
Go ahead. So this laser clean is going to need what you call dark glasses. Because, you know, we don't want to ruin our eyes, but of course, this is high tech, a lot of light going on, or whatever you want to call a laser. We want to protect our eyes. We're going to wear our dark glasses, and here we go. So, just by going over with your laser cleaning, you're going to remove the grease, the paint, and the rust.
Exactly.
All in one shot.
Exactly.
I got to see this. I got to see this.
Normally, we wash through the pressure machine, so the water pressure machine. So today for the Nick Garage video, we need to show how the laser cleaning works very well. So without washing,
Without cleaning, without nothing.
Exactly, we're gonna see how it works.
And this is the way I took them out of storage. They've been sitting in the humid garage for many, many years. So now make them look new.
Okay, perfect.
Let's see.
Yeah.
Okay, go ahead. Here we go. Yes, this is good, man. Wow, this is awesome, man.
You need, we need to.
Wow, you took all the rust out completely.
Repass. Sorry?
You took all the rust out completely.
Yeah, yeah, but we need to work with another adjustment for the machine, and
Okay.
after that we're gonna see the piece like look like perfect.
Man, it's looking good already.
Yeah, yeah,
It's looking good already. Wow. Where were you guys years ago? Wow, this new high tech.
At the good place, I think. Yeah.
No, but this high tech stuff seems to be working. I love it. Never entered my mind back in the day when I'd be in the alley, and then years later, 50 years later, I see laser cleaning. Never thought of that. You know, for an old school guy like me, this is totally brand new, high tech technology that I've never seen before. Damn, it's good, man. Let's go. Go ahead, finish it off, man.
There we go.
This is fabulous, just fabulous. And that rust was pretty well cooked, thick on the cast iron.
Yeah.
It looked like the Titanic before you got to it. Anyways, you know, this is really impressive, really, really impressive. But I realized something. You know, this is nothing like sandblasting because you don't make any dust or anything like that.
No.
Like there's sometimes I have a case that I need to do sandblasting to do on the car. But when you sandblast, it makes a lot of dust and everything. But with this, creating no dust or sand anywhere, that's perfect.
Yeah,
While
exactly,
the item
exactly.
is on the car without removing it.
Yeah, for some.
This is crazy.
Yeah, yeah, it's very crazy and it's very clean.
Very nice, very nice.
You don't need to clean the all garage and the car after.
No,
the
I know
cleaning.
it.
No.
I noticed there's nothing on the floor.
Yeah, yeah.
It just disappears.
Yeah, exactly. It's disappear. And the little dust of rust you see there, you just need after before you need to clean it.
I know. I gave
For today, you know,
I gave it to you with
yeah.
all the loose rust on. I just wanted to see how far we can go.
Yeah.
That one is not as bad, but this was real bad shape.
Yeah, yeah.
Nick has certainly given the laser cleaner a good challenge today, not even pre-washing or brushing these heavily corroded parts. Now he wants to see what the machine can do with the combustion chambers of these crusty old heads.
We did the outside of the cylinder head, which was really bad. But right now, I just wanted to tell Mike, I just want to do the chambers, not the surface, because we're going to plane the head a little bit. So now I need to do the chambers, and he's going to the 300 watt machine, the little one, away from the 2000 constant watts.
Yeah.
So let's see what that one could do on the chambers.
Yeah. All right.
Okay, Mike, give us a show.
I need other adjustment for this kind of job.
Okay.
But, like I say, I adjust the machine very fast just to show
Okay. All right.
what kind of design we can do with the post machine. So how do you like it, Nick?
You're good. Keep going. It looks
not,
good.
It's not very clean now because, like I say, it's very fast adjustment.
Okay. All right. So you're gonna have to.
I'm gonna continue with the only straight line because the straight line is very simple to just work on it when it's not.
Take your time, Mike. Take your time.
All right.
Mike, it's good, man.
Yeah.
It's good. You don't need to go any further. This is perfect.
Okay.
This is perfect. It's the big chunks of rust I want to take out. This is good.
Okay.
You know, after I do the valve job, the bowl blending, valve guides, planing, it's gonna look like brand new.
All right.
I just wanted to remove most of the rust. It's not bad at all. And you know, you didn't even have to do this clean because I'm just gonna pass the Dremel just to smooth out the chamber so you don't have to go crazy.
Okay.
All I want is the major rust and that's it.
Oh, okay.
Simon takes over with the 2000 watt constant laser and makes short work of the next combustion chambers.
That's it. That's good enough. You don't need more. You don't need more than that. It's good. Like I said, I'm going to pass a little drum after. You took off all the high spot of the rust.
Perfect.
It's all good, man.
Well, as you can see, this one is way.
Yeah, this is more powerful.
Yeah, it's powerful, and it worked well on the like engine piece like this because like it's able to take some heat. Because this machine, like the transfer of heat, is way bigger than this one.
I noticed.
But as a piece of engine, you can take it.
Okay, let's do it. You're doing good. You're doing good. 2 more chambers. Hit it. Hit it. That's it. And you don't have to do up here. Don't worry about that. Just here. Plus
Okay.
C, plus C, just to see. That's good, man. You even got inside the port. That's not bad. It's good. It's good.
Good.
It's good.
Nick has been working with dirty, rusty old parts since his days in the back alley. He's seen new technology rise and change the automobile industry. But he never imagined he would one day have laser beams to help him clean and prepare these rare parts for his projects.
So there you have it. We've done cast iron, brittle cast iron. It was really pretty sad the way it was. We did cast iron, we did cast aluminum, and of course the sheet metal on an oil pad. It was all great. But also, I noticed you took a small shot on cement.
Yeah.
That even cleaned the cement.
Do you want to see
And-
more, Nick?
No, I don't need to see anymore. You just zapped that for a second. That is enormous what I saw. So I just want to say to you guys a big thank you. You guys have a great machine here, a nice invention you've done. And you know that anybody wanted to do work on the bench is great, but this thing under a car, if you want to do work on a car without doing any dust, this is the perfect ideal machine which you guys have.
Yes.
So I wanted to say a big thank you for coming by. Simon,
Thank you.
thank you. And thank
you,
you,
Nick.
Mike.
Yes.
If our viewers want to get in touch with us,
Yeah.
where do we go?
Well, we're all around the internet, TikTok, Instagram, Facebook. We have our website. If people have any question about machines, we made a little forms because I know most people, they want to know the price, they want to know depending on the industry they work in. So we send a little form just to help them figure out what's the best machine for them.
So we're old school, but I like to bring in the new stuff, and here we have it. And it's also made in Canada, you guys. And now, don't forget to press the like button, subscribe to my channel. And don't forget, you guys, there are a lot of viewers out there watching my channel, or should I say my videos, but you're not subscribed. So please hit that button and subscribe. And thanks for watching us here on Nick's Garage. And you guys, if you look down below the video, we have a whole bunch of merchandise that you guys can buy. So whatever you like, buy it, love it, wear it, and enjoy it. And help spread the word of Nick's Garage. And if you have some time, check out our Patreon page. We have extra content and you guys can watch it and take it from there. And we'll see you next time.